Now we'll solve the next part of dual nature of radiation and matter. Dual nature of radiation and matter. So now next question is 12.1. It is asked in 2017 NEET. Photoelectric threshold wavelength of silver is given. Threshold wavelength, that is lambda naught, is equal to 3250 into 10 raised to minus 10 meter. Velocity of electron ejected from silver surface is given. That is V. Okay, you have to find the V, right? Final kinetic energy ka V. Of wavelength. Ultraviolet light of wavelength is given. That is lambda of a final is given 2536 into 10 raised to minus 10 meter. So H value we know in Planck constant, that is 4.14 10 raised to minus 15 electron volts taken. It will be given, right? C is C 3 into 10 raised to 8 meter per second. So these are the data given to you. You have to find the final velocity, right? For 12th number. So lambda naught we know. So it is defined as E naught equal to H mu naught. So write in lambda form, so it will be HC upon lambda naught, right? So you can find this one, lambda naught, initial threshold frequency. This is called threshold energy. Threshold energy. So when we multiply Planck constant and C, it will be equal to 12375 electron volt. So you can just multiply it, you will get, right? So HC is equal to 12375. Remember this one value. Divided by lambda value we know, right? That is 3250. In electron volt we have converted. So divide these two, you will get 3.81 electron volts. Understood up to this point? Hello. Are you getting, Manoli?
Yeah.
Okay. Now, next, ultraviolet wavelength is given, right? This one. So find energy for this also. So final energy will be equal to Hc by lambda F. So it is 2.12375 electron volt divided by lambda value put here. So it is 2576. So after dividing, you will get 8.88 electron volt. Right. Now we know the formula. So it is nothing but 1/2 mv square equal to E minus E naught. E value we know, that is 4.88 minus E naught value we have calculated, right? Put here. So it is 8.31 electron volt. So how much it is? It is 70.1 electron volt, right? So it is equal to 1/2 mv square. Now see in the next slide. So 1/2 mv square is equal to how much we have got? 1.07 electron volts. So we have to find just V, right? So take the square root. It is 2 into 1.07 electron volt divided by N. Now put the value 2 into 1.07. 1 electron volt is equal to 1.6 10 raised to minus 19. So put the value of E volt 1.6 10 raised to minus 19 divided by mass of electron is 9.1 10 raised to minus 31. So you will get V value after calculating 0.61 into 10 raised to 6 meter per second. Understood? So let's see the concept of photoelectric effect. Photoelectric effect, or it is also called as Einstein equation. Very simple concept. This is your metal, and when electron is coming out, that is called kinetic energy final. So here kinetic energy initial, and this is your work function K naught. So this energy is divided into two parts, this and this. So when we use law of conservation of mass, law of conservation of mass, or law of conservation of energy, ठीक है, तो initial kinetic energy is equal to final kinetic energy. So KEI can be written as equal to K naught plus KEF, right? So this is the first equation we have to remember. So write in kinetic energy form now. So it is equal to 1 upon 2 mvi square equal to 1 upon 2 mv naught square plus 1 upon 2 mvf square. So this will be the second equation. Next, energy will be equal to E equal to E naught plus EF. This is the third equation. Next can be written as E equal to H mu I, H mu naught plus H mu F. Mu is frequency here, H is Planck constant. Now, next form will be Hc upon lambda I equal to Hc upon lambda naught plus Hc upon lambda final. So these are the same equation, but written in the different forms, right? All are called Einstein equation only. And effect is called, experiment is called photoelectric effect. Understood? Sometimes this is also called as threshold one, this one. In every equation. Threshold energy, threshold kinetic energy. This is threshold kinetic energy. I will write here. This is threshold kinetic energy, E naught. Threshold energy, mu naught is threshold frequency. Lambda naught, threshold wavelength. Understood? So write all the form of this equation. These are the four forms in which we write the equation of photoelectric effect. Next is 13 number, right? So see the 13 question क्या बोलता है? Electron of mass m with de Broglie wavelength lambda fall on the target in an X-ray tube. Cutoff wavelength lambda naught of the emitted X-ray is given. So electron of mass m, lambda L fall on the this cutoff wavelength, that is lambda naught is given. Okay. So we have to just relate these two. So initially I have written E equal to H mu, right? It is can be written as SCY lambda, right? It is also equal to P square upon 2m. So these all are energy, initial energy. Understood? यहाँ तक समझा आपको?
हाँ सर.
Okay. So energy will be equal to A upon 2m. And de Broglie is lambda equal to H upon P now. So instead of P, I will write H upon lambda. So put here in this formula, this one. So E will be equal to h upon lambda whole square divided by 2m. So it will be equal to h square upon 2m lambda square equal to E. Understood? So for certain maximum wavelength will be equal, and here energy is given equal to E naught. So E value we know, right? This is your first equation. So it is nothing but h square upon 2m lambda square equal to hc by lambda naught. So we have to find this one, lambda naught. This h and this h will get cancelled. So lambda naught equal to, multiply here with c. So it will be 2m c lambda square upon h. So this will be the threshold wavelength in the form of mass, speed of light, lambda and h. Right up to this point. The next question that is asked in 2016. Previous one is also asked in 2016. This is 14. Photon with energy equal to 5 electron volt are incident on cathode. Okay, this is incident on cathode, written as C. In photoelectric cell, maximum energy of the emitted photoelectron is 2 electron volt. So energy is emitted, that is equal to 2 electron volt. When photon of energy 6 electron volt or incident. So this is the case 1. For second case, when 6 electron volt energy is incident on cathode. This is your cathode. So no photoelectrons will reach the point to anode. So it is not reaching to anode point A. So if the potential, a stopping potential of A to C is, we have to find the potential difference. ठीक है, तो बहुत सिंपल है, जो पहले बताया था वैसे ही है, वो रूल्स अप्लाई करेंगे. तो इनिशियल काइनेटिक एनर्जी इक्वल टू के नोट प्लस के एफ. ठीक है, सो हियर आई विल राइट के जीरो एज 5 वर्क फंक्शन प्लस के एफ इक्वल टू के आई. So 5 will be equal to what? It will be equal to Ki minus Kf. Right. So it is given. Final value we know, right? And initial. So it will be 5 electron volt minus 2 electron volt. How much it is? 3 electron volt. Pi v volt. ठीक है, ये समझ में आया? बहुत माइनस सिंपल तो करता है. 5 minus 2 करेंगे तो 5 मिल जाता है.
हाँ सर.
Okay. In the similar manner, we use here 6. So this 5 we know, right? This is equal to 5. So 5 we got 3 electron volt. Now put in the equation, that is Ki equal to 5 plus K. So Ki is 6 electron volt in second case. 5 will be same because we are using the same material, that is cathode only, right? So this is equal to this. So it is equal to 3 electron volt plus Kf. So Kf will be equal to 3 electron volt, right? So stopping potential will be negative of that. So write one line here, stopping potential is negative of 5. So it will be minus 3 electron volt. बहुत सिंपल था. देखो 15 में क्या बोलता है? Which of the following figures represent the variation of particle momentum and associated de Broglie wavelength? ठीक है, मोमेंटम एंड डी ब्रोगली वेवलेंथ के बीच में रिलेशन निकालना है तुम्हें. ठीक है, तो कैसे करेंगे? ठीक है, तो देखो डी ब्रोगली वेवलेंथ लैम्डा इक्वल टू क्या होता है? एच अपॉन पी. तो एच तो कांस्टेंट है, तो लैम्डा इज इनवर्सली प्रोपोर्शनल टू मोमेंटम. ठीक है, मतलब ये y इज इनवर्सली प्रोपोर्शनल टू x हो गया ना. तो इसका ग्राफ कैसे आता है? y इक्वल टू x. सिंपल है. अगर नहीं समझ में आए तो ऐसे वैल्यू निकाल भी सकते हैं, ऐसे करके. ठीक है, ये x ले लो, ये y ले लो. अगर x का वैल्यू तुम बढ़ाओगे तो y कम होगा. ठीक है, तो देखो x का वैल्यू इंक्रीज क्या होगा? ये आपका इंक्रीज है, और नीचे आ रहा हूँ ऐसे, तो ये आपका डिक्रीज है ना, ठीक है। तो ये ग्राफ ऐसे आएगा, चेक कर लेते हैं। अगर 1 डालोगे तो 1 आएगा, मतलब x का वैल्यू 1 है तो y 1, देखो, ठीक है, ये पॉइंट मिलेगा। अगर x का वैल्यू तुम 2 डालोगे तो y का वैल्यू 0.5 आएगा। तो यहाँ पे देखो 0.5 आएगा, 2 डाला तो 0.5, ठीक है। 3 डालेंगे तो 4 डालो, तो ये क्या आएगा 0.25, ठीक है, यहाँ तक क्लियर है। तो 4 डाला तो 0.25, मतलब x का वैल्यू जैसे जैसे मैं इंक्रीज कर रहा हूँ तो y का वैल्यू कम होगा, क्योंकि इसको बोलते हैं इनवर्सली रिलेशन, इनवर्सली प्रोपोर्शनल। चलो लिख लो फटाफट। देखिए 16, a certain metallic surface is illuminated with monochromatic wavelength of light lambda, और स्टॉपिंग पोटेंशियल, ठीक है। तो ये मेटल के ऊपर गिर रहा है, तो स्टॉपिंग पोटेंशियल फॉर फोटो इलेक्ट्रिक करंट इज गिवन, दैट इज 3 v नॉट। इफ द सेम सरफेस इज illuminated with the light of wavelength 2 lambda, ठीक है, यहाँ से फिर से गिराता है 2 lambda, स्टॉपिंग पोटेंशियल इज v नॉट इस टाइम, ठीक है। सेकेंड केस के लिए थ्रेशोल्ड वेवलेंथ ऑफ द सरफेस ऑफ फोटो इलेक्ट्रिक, तो थ्रेशोल्ड वेवलेंथ निकालना है तुम्हें, ठीक है, आस्क्ड इन 2015। So see here, same formula we will apply. So initial kinetic energy equal to threshold plus final kinetic energy, right? So right here phi equal to ki minus kf, right? So put the value, 3 electron volt is given, 3, don't talk, 3 v naught plus 5 equal to, I will write energy in form of AC upon lambda. So for the second case, it will be equal to 2 E V naught plus 5 equal to AC by 2 lambda. It is given 2 lambda, na? So it is 2 lambda. So now solving 1 and 2. So you can just subtract it. So this will be minus minus. So this point will be get cancelled. This one is equal to cancel. So 3 minus 2 is 1. So electron volt equal to AC by lambda. AC is common. 1 minus 1 upon 2. So it will be AC by 2 is equal to electron volt. Understood? Now put AC by lambda, AC by 2 equal to EV naught, or instead of EV naught. So we'll get 5. So put here. So 3 EV naught plus 5 equal to AC by lambda. Put here E naught value. So it is 3 AC by 2 plus 5 equal to AC by lambda. So find 5 value. So it is AC by lambda minus 3 AC by 2. So 5 LCM is 2 lambda. So minus of AC by lambda आएगा, ठीक है, 2 lambda. ये समझा आपको?
हाँ सर।
ओके,
हाँ सर।
लिख लो फटाफट। ठीक है, ये देखने में तो ये लगता है, लेकिन होता बहुत ईजी है. See the next numerical 17 number. When the energy of incident radiation is increased by 20%, suppose initial energy is E and I am increasing it to E2 is 20% of E. The kinetic energy of photoelectron emitted from metal surface increased from 0.5 electron volt to 8. So this is incident on this metal. So kinetic energy KEF. In the similar manner, when it is following this on this metal, so kinetic energy is given finally. So this is given 0.5 electron volt and increase to 0.8 electron volt. So work function you have to find, just find the work function. Work function will be same for those. बहुत सिंपल है, इक्वेशन में डाल दो. तो Ki इक्वल टू 5 प्लस Kf. ठीक है, तो इनिशियल इज E, pi we have to find it, plus finally no 0.5 electron volt, right? So write for the second case also. So increase by 20% now, so it will be 0.02 E plus E, so it will be equal to 1.02, or it is equal to 1.2 electron or energy. So for second case, it will be equal to E equal to 5 plus K. So E value we know, that is finally we know 0.8 electron volt equal to 5 equal to E is 1.2 electron. Now solve it. These two equations, this is 1, this is 2. So I'll write here second one, 1.2 E equal to 5 plus 0.8 electron volt. Subtract this one, upper one. So this will be minus, minus, minus. So this and this will get cancelled. So this will be 0.2 electron equal to 0.3 electron volt. Understood? So now put E value in the first. So E value we got 3/2 electron volt. Right. This is the third one. Put third in first. So first is E equal to. So E is 3/2 electron volt plus 5. Equal to 5 now. Plus 0.5 electron volt. So 5 equal to क्या आएगा? 5 equal to 3/2 electron volt minus 0.5 electron volt. So it is nothing but 1.5 electron volt minus 0.5 electron volt. It is equal to 1 electron volt. 5. Okay, after putting the value.